I'm Shiva sir. So in the previous class we discussed about reflection and definition of reflection and terms. What are the terms? Incident ray, reflected ray, normal line. So how it will be? Everything we discussed. Okay. So in that, what are the points are there? So we discussed in the previous class. And incident ray, reflected ray, normal line, and the line which is perpendicular to the plane surface, that is called normal line. Angle between incident ray and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. So in the previous class what we discussed, so I'll recall. So if you take so this is incident ray and this will be considered as a reflected ray, and I am taking this the normal line which is perpendicular to the plane surface. So the angle between incident ray and normal line is called angle of incidence. So I am taking this angle of incidence, and angle between normal line and reflected is called angle of reflection. So the line which is deviating through the surface, that is called deviator line. So the angle between this one, so reflected and deviated line is called angle of deviation. So we can consider, and so the light which is incidenting on the surface, that is called incident ray. The line which is reflecting back from the surface, that is called reflected ray. The line which is perpendicular to the plane surface, that is called normal line. So now the angle between incident and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. Angle between deviated line and reflected is called angle of deviation, right? And one more point, loss of reflection. Loss of reflection, so nothing but angle of incidence is equal to angle of reflection. Angle of incident is equal to angle of reflection, and incident ray, reflected ray, normal line lies on the same plane. Once again, incident ray, reflected ray, normal line lies on the same plane. So these are the laws of reflection. Laws of reflection. Laws of reflection, very very important. Laws of reflection. So be very clear with that. This topic is very important. So in MCQs also very very important topic. So now we will so in the previous class we'll discuss about we discussed about regular reflection and irregular reflection also. So what is the regular reflection and irregular reflection? Regular reflection is nothing but, so I'm taking this plane surface. So I'm taking this plane surface, I'm considering. So when the light is incidenting on it, the light incident on it, so if I'm taking, so incident beam, so I'm taking this incident beam, because all lines are parallel to each other. If the incident beam is parallel, so then reflected beam also parallel. This reflected beam also parallel. This type of reflection is called regular reflection. This type of reflection is called regular reflection. Clear? So if you take irregular reflection, so irregular reflection is nothing but, so the reflected beam is not parallel to each other. So if I am taking this the surface, I am considering this a surface. So whatever you are considering the reflected beam, so this the incident beam, I am taking this incident beam like this. But the reflected beam is not parallel. Actually this surface is also not smooth surface. The surface is rough surface I have to take. So this is a rough surface. Okay. So incident beam is parallel. So this is a rough surface. Rough surface I am considering. So the reflected beam is not parallel. So it will be moving in different directions. So this one direction. So this another direction. So like this we can take. And so we can also like this, will like this also we can consider. It's not parallel, so it moves in a different direction. So this is called irregular reflection. So irregular reflection. Irregular reflection. Clear? Yes. So this about irregular reflection. Next, so we'll see one more about plane mirror. Regular reflection, irregular reflection completed. Then we can consider one more thing is plane surface. So plane surface, if you take, I am taking this plane surface, I'm considering this plane surface, yes. So if you take the point object, I'm considering the point object. This is a point object. So here I'm considering the point object. So is it clear, right? So from this light rays are coming from this point, and from this point also light rays are coming. So after reflection, so light rays are moving like this. Okay. So here you can consider this is the incident ray, this is incident ray, this also incident ray, this is a reflected ray, this also reflected ray, right? So if you extended this reflected light ray, so those will be meeting at one point, so that is called virtual image. So here is real object, real object. So here you can observe real object, understood? So this is the incident ray, this is the reflected ray, reflected ray. So if you extended this reflected ray, that reflected light is meeting at one point on the principal axis, so their real image will, virtual image will form, virtual image will form. So we can observe here, and one more diagram I will draw, so you can see here. One more diagram is, so 1 minute. Yes, so here if you take, I am taking this one more diagram, diagram if you consider, right? Yes. Now I am considering the object. So light rays are coming like this. These are the light rays. These are the light rays. I am taking this the incident ray. This also incident ray. Okay. So what happens after incidenting? So this reflected light ray will meet at one point. So here you can observe here. So this is a reflected ray. This also reflected ray. Understood? Yes. So if you extended this light rays, those light rays will meet at one point. So if you consider, okay, so here you need to observe. So what we can observe here, this is the virtual object, virtual object. So how we can understand? How we can understand this is a virtual object, virtual object. Why? So these are the incident rays, these are incident rays. So we are extending those incident rays. Those incident rays are meeting at one point. Those incident rays are meeting at one point. Okay. So here you can observe this is the reflected ray. This is also reflected light rays. So those reflected light rays are meeting at one point. So that is called real image. Real image. So this is the virtual object. So by seeing these two diagrams, you can conclude that. So here from this object, from the object light rays are coming. So after reflection, light rays are, if you extended those light rays, reflected light rays, so meeting at one point. So that's why that is a virtual image and real object. So whereas light rays are coming from infinity, after reflection, those light rays are meeting at one point. So actual reflected light rays are meeting at one point. That is called real image. That is called real image. So here you can see if you extended this incident rays are extending. So those incident rays meeting at one point. Okay. So that is a virtual object. Virtual object. Yes. So I hope it is very clear. If you have any doubt, you can now message. So I'll clarify your doubts. Yes, I'm moving into the next topic. So this is about the plane mirror, and next one, if you consider one more thing, that is characteristics or properties, characters of the image formed in the plane mirror. So how it will be? So if you take the plane mirror like this, I'm taking the plane mirror. Okay. So coating will be there. Coating, I am considering this the coating. So principal axis I am taking now. So I'm considering this object. So this is the object I am taking. So one light ray I am taking like this. How many light rays are required to form the image of the object? Minimum light rays. How many light rays are required to form the image of the object? Minimum light rays are required. Two light rays are required to form the image of the object. Yes. So now we can see. So this is the object height size I am taking AB. So one light I am taking. So another light I am considering here. this another light ray. Okay, so then it will be reflected back. So like this I am considering. So one more light I am taking here, it will be reflected back like this. Understood? So got it. Now you can observe, if you extended those light rays, if you extended these light rays, so light rays are meeting here. Yes, so yes, so you observe here. I hope it is very clear to you, right? This is the A dash and B dash. So this is the object. So one light I am taking like this, it will be reflected. After reflection it is moving back. Here also one more. So like this also we can take, like this also we can consider. So one light I am taking this side, so it will be reflected back. Another light ray this side, it will be reflected back. So if you extended this reflected ray and this reflected ray, so that will be meeting at one point. So then we are drawing this one. So this is the virtual image. So this is the real object. So by seeing this one, we can conclude that, so the object distance is equal to image distance. Object distance is equal to image distance, and size of the object is nothing but height of the object is equal to height of the image. Height of the object is equal to height of the image, and it also shows lateral inversion. So what is the lateral inversion? Lateral inversion is nothing but the phenomena of converting of left side of the object to be right side of the object appears to be left side. So best example I am taking here. So I am considering, so here you can observe here. So B letter you can observe here, it appears like this, reverse manner. Yes or no? Yes. So you can observe here. So normally letter B looks like this. So whereas in the mirror it appears here. So what happened here? Left side of the object appears to be right side. So we can able to see, even if you stand in front of the mirror, if you stand in front of the mirror and raise your right hand, it appears in the left side. If you lift your left hand, it appears in the right side. It appears in the right side. Okay, the phenomena of appearing of left side of the object to be right side of the image and right side of the object appears to be left side of the image, that is called lateral inversion. So these are very important. These 3 points are very important. One is object distance is equal to image distance, height of the image is equal to height of the object, height of the object is equal to height of the image, and it also shows lateral inversion. What is the lateral inversion? So right side of the object appears to be left side of the object appears to be right side. So that is about lateral inversion. Okay, yes. So now next we'll talk about spherical mirrors. Spherical mirrors we'll discuss in the next class. So this is about plane mirrors. Okay, so reflection, regular reflection, irregular reflection. So object, image, and next one, so property, characters of the image formed in the plane mirror. So that is about today class. If you like this content, do like, share and subscribe to Student the Brand. Thank you so much. Thank you.